The science is clear. Our climate is changing. Yes, the climate has and always will change, but the recent change caused by human-induced emissions of carbon dioxide and other greenhouse gases over the past century means that the climate is changing at a much faster rate. In fact, global surface temperature has already increased by just over 1 degree Celsius compared to pre-industrial levels. While that doesn't sound like much, each small change intensifies our exposure to extreme weather conditions. To understand the impact of such small changes to average temperatures, we can think of them as a bell curve, with extreme cold and hot at either end, and the bulk of temperatures in the middle. A small shift in the centre means more of the curve touches those extremes, so heat waves become more frequent and more extreme. But it's not just about temperature. We're also experiencing changes to rainfall, to winds, coastal areas, and oceans. For example, small shifts in the circulation of air in the atmosphere and water in the ocean can influence rainfall patterns. Less rain, in combination with increased temperatures, draws more moisture out of the ground and the vegetation, which is making our environment dry. This can lead to more frequent and more intense bushfires, making them increasingly difficult to control. In a nutshell, climate change is not just about slightly increased average temperatures and slowly rising sea levels. It will cause infrastructure damage and disrupt power supply and trade. It will impact water availability and agricultural production, and can even lead to the displacement of whole communities. It will impact our health and our economy's ability to function as it has to date. Strong and sustained reductions in emissions of greenhouse gases would limit these impacts of climate change. But even if we were to stop emissions today, the world would not suddenly stop warming. It could take decades to see global temperatures stabilise. Other changes, such as sea level rises, are irreversible over hundreds to thousands of years. That's why we must do both: reduce greenhouse gas emissions and adapt to our changing climate. The question is, how? How do we determine which adaptation actions we should focus on and where we can achieve the greatest benefit? Also, is adapting to climate change all doom and gloom, or are there opportunities we can leverage? This is where the value of risk management comes in. Climate risk management is the process of identifying and addressing risks that may arise from climate change. It involves understanding how a changing climate can impact your organisation, your people, and your assets. Because we are looking into the future, the assessment is done across one or multiple defined time horizons. For example, we may want to investigate risks relevant for the near future, so we are using climate projection data that shows us what a future climate could look like, let's say, in 2030. Here, it might be useful to explore how the climate is already affecting you now. Are workers already impacted by heat? Are systems already exposed to hazards? What are you currently doing to reduce those risks? And what might this look like if conditions get worse? We can also look at climate projections for the far future, keeping in mind that society might have changed by then, and the conditions we are facing in 2090 depend on our actions now. This is why risk management doesn't stop here. We have to develop and implement adaptation measures to address priority risks now. Whether you are assessing climate risk in the enterprise, sector, or at the state level, risk management takes a holistic approach to look at possible consequences strategically and across the entire system. With climate risk assessments, we are able to make smarter decisions and prepare for what's to come. The sooner we act, the more effective our adaptation response will be. Let's do this together. Let's start today.